Hey everyone, welcome back. In this video, we're going to have a look at the variable valve timing mechanism operation and diagnostic. And of course, we will have a look at the VVT solenoid valve as well. As you guys might know, we already have some other videos on the channel for valve timing fault codes like P0011, P0014, P0016, P0017. Which are links to the variable valve timing system. On those videos, I explain how to check the solenoid, how to check the camshaft or crankshaft position sensors in case that you have P0016 or 17. But it's really important to know that sometimes when you have engine timing fault codes, problem could be on the camshaft, on this variable timing mechanism. So in this video, I'm going to explain how to diagnose this one to make sure if problem is mechanical, because sometimes problem is mechanical, not electronic. So we will see a step by step how to test this one on the camshaft. And of course, I will explain how to test this solenoid valve as well. These components are removed from a Ford territory, which does have dual variable valve timing mechanism. This is actually one camshaft and one solenoid from that engine. But if you check the engine, you have two solenoids and two camshaft with valve timing mechanism, of course. Before starting the video, if you guys haven't subscribed the channel yet, please don't forget to subscribe and like the video for supporting us. And if you're interested to learn more about engine diagnostic, we have a 4 hours online course for all engine sensors diagnostic. On that course, you will learn a lot and you will get a certificate of completion at the end as well. You can find the link to that online course in the video description or the first comment down below. All right, let's start. So as you might know, when we have variable valve timing mechanism, in addition to the mechanical timing adjustment that you do at the very beginning when you set the timing between the crankshaft and camshaft, we have a valve timing mechanism here that engine can control for getting higher performance and efficiency from the engine during different engine running conditions. So it means this valve timing mechanism over here, which you can see it just right now, can adjust the valve timing by engine oil. So it means when engine is running, if ECM wants to adjust the valve timing, it's gonna activate this solenoid valve. The solenoid will provide the engine oil from these passages to the VVT mechanism, and inside the VVT there is a vane which is gonna rotate. So as a result, the entire camshaft is gonna rotate toward the advance or retard. Majority of the valve timing mechanism that you see on the market, they are operated by engine oil. As I explained, there are some of them that we call them EVVT or ECVVT that are controlled electronically. On some engines, we only have one VVT on intake camshaft. On some of them, we have two, one for the intake, one for the exhaust. So it's going to be dual VVT engine. On this engine, on Ford, they call it VCT, and this solenoid is called VCT Solenoid as well. But it's called differently on other engines. Some cars, they call it VVT. Some cars, they call it CVVT for continuously variable valve timing. And this component in Ford is called VCT Solenoid or VCT Actuator. On some other cars, it's called VVT Solenoid Valve or OCV. So basically, you know the operation. Engine oil is provided to this solenoid valve. And anytime that ECM wants to adjust the valve timing, it's going to activate this solenoid valve. Solenoid provide the oil from here, and the internal vane of this VVT will rotate to rotate the camshaft. And when ECM does all that thing, it's going to look at this target wheel at the end of the camshaft through the camshaft position sensor to make sure that VVT is functioning properly. So it means if ECM is activating this solenoid valve, but this VVT is not functioning properly, of course, the adjusted valve timing is not going to be achieved, and ECM will set you a fault code. So some fault code like P0011 or P0016, they are for the intake VVT. P0014 and P0017, they are for the exhaust VVT. So checking this one is quite easy, checking this valve. We have some other videos on the channel on different cars to show you how to check this one. So sometimes problem is not even mechanical, it's not electronic. This valve is dirty over here, so you need to take this one out to clean it. I'm gonna remove this one right now to take it out to have a look, and then I will show you how to inspect it as well. So we can take this one out, just be careful when you are taking this one out. This is the VCT Actuator or VVT Solenoid valve. As you see, it's very clean. So if you see oil sludge over here, that oil sludge can block the oil passage. So it must be clean. This one is pretty much clean. You can take the filters out on here as well to clean everything as well. But right now, because I'm going to show you how to test that one, let's move forward very quickly. So the first step is to check this one for any contamination. If it is good, we can go to the next step to check the solenoid itself. So I'm going to put this one aside. So for checking the solenoid, because this is a solenoid, it does have a coil inside, so we can check the internal resistance of the solenoid. On Ford, internal resistance value should be something between 7 to 14 ohms. If I check it right now, I should be able to read that value. So as you see, we are getting 7.2, which is exactly what we are after. So if you are checking this resistance and you are getting no reading, it means there is open circuit. Or if you are getting very low value, it means there is short circuit. So it means this solenoid should be replaced in that case. We can also activate the solenoid, because when you check the resistance, you are checking the electronic side of the solenoid. If you activate it, you're going to check the mechanical side of it as well, because when the solenoid is energized, it's going to move the plunger inside. So for that, you can use the battery or just this 9-volt battery, which is much more safer. So I'm going to keep this one off, positive and negative, just like this. And then when I turn it off and on, you don't see the spool right now. If you take these ones out, you can see it. But right now I can hear the valve operation. I can hear the sound. So you hear it. When valve is operating, you can hear the valve operation sound. This confirms that the mechanical side of the solenoid is good as well. I've seen many cases that after having the engine timing fault code, some guys go straight away for replacing this solenoid valve. Sometimes the problem is not from here. It could be from the mechanical side that I will explain very shortly. But how can I check this one? As I said, if solenoid is good, oil from here is going to get into these passages and it will activate the VVT mechanism. But if there's anything wrong in here, what's going to happen? Inside the variable valve timing, there is a vane, as you see right now on the screen, and there is a locking pin. Basically, when engine is off, this valve timing mechanism is locked. Generally on intake, it's locked on maximum retard. On exhaust is locked on maximum advanced. And when you start the engine, when engine is warming up, gradually ECM will activate the solenoid valve to provide the oil from here. So oil is going to get into the VVT to unlock the pin, and then it will rotate the vane toward the advance or toward the retard based on the original position. So right now, as you see, if I try to rotate this, it shouldn't rotate. So it means the first step is just to make sure, grab the camshaft from here and try to rotate the VVT. If you see VVT rotates freely right now, it means the locking pin is broken or it's stuck open. It means it's going to be a problem. So in that case, you have to replace the entire VVT. But right now, as you see, I cannot rotate the VVT. So it means so far everything is okay. But the next important step, something that happens more frequently, is I want to make sure if that locking pin gets released right after oil is provided. So it means right here, you have two passages over here, right? The first passage over here is for the advance and this one is for the retard. So it means this one is right now at maximum retard. So if I provide the air from here, I should be able to rotate this one toward the advanced, because if oil from here gets to the VVT, it's going to unlock the pin and it will rotate it toward the advanced, because intake VVT is locked at maximum retard. So we need to rotate it toward the advanced. Right now, if I provide the air pressure from the advanced passage, I should be able to see that this VVT rotates, or at least I should be able to rotate it manually myself. If I provide the air from here and VVT doesn't rotate, it means the locking pin inside the VVT is not getting released, which is actually a sign of having a bad VVT. So as you see, if you look inside, this one is spring loaded. So it means after providing the air from here, most likely I need to just rotate this one by my hand after that locking pin is released, because the spring is just holding this one back into place. On some models, you see only the exhaust one is spring loaded. In this car, both intake and exhaust, they are both spring loaded. So what I do, I tape around here because I want to make sure that there is no air leak. I tape around here, and on the tape, I will make a hole just over one of these, passages, just right there. Then I can apply the compressed air from there to make sure if that locking pin gets released or not. Quite easy. So grab the tape and tape around here, nice and clean. Then just grab a screwdriver and make a hole just right here, very carefully. So right now, as you see, I taped around here, I close the passages, this one is open. I'm gonna just go for applying the air pressure from here to see if I can release the locking pin to confirm if this one is good or bad. So right now, as you see, I have the camshaft right here with the camshaft variable valve timing. I have taped around here to make it easier to test the VVT itself. So right now, as you see, VVT is locked, so I can't rotate it. But when I apply the pressure, as you see, it rotates. This shows that the air pressure can release the locking pin. So that locking pin is not stuck. So look at here. So this is one sign. And you need to make sure after you stop providing the compressed air, this one should be locked again. This confirms that the VVT mechanism itself is okay and that locking pin itself is working properly. If you apply the air pressure and you see this variable valve timing mechanism doesn't rotate, it means that locking pin inside this mechanism is stuck. That's why you have engine timing fault code. Because if that locking pin doesn't get unlocked, doesn't really matter if solenoid provides the oil pressure in here, because this is not going to work, because oil pressure cannot release the locking pin if it is not moving. So the timing mechanism is not going to adjust the valve timing as well. That's exactly when you will have engine timing fault code when engine is warmed up. All right, guys, thank you very much for watching. I hope you enjoyed the video. We have some other videos for checking the engine timing on the channel that I explain everything, how to check the VVT solenoid valve on the car as well. You can find the link for that video in this video description. Thank you very much for watching. Please don't forget to visit the channel page and subscribe for more videos.